Sometimes the ozone that causes this comes from way up here. Yes, there, the stratosphere, where jetliners fly around. Ozone in the stratosphere typically stays up there and protects us from UV rays. But sometimes the gas travels into the lower part of Earth's atmosphere. Watch the way ozone behaved here. As the low-pressure system moved northeast, ozone-rich air descended downward. Winds took a hold of it, stretching it in different directions and bringing it all the way to the ground along Colorado's northern Front Range. This is called a stratospheric intrusion. The EPA says an acceptable amount of ground-level ozone is 75 parts per billion. In early April 2012, that number went beyond healthy levels.
When stratospheric intrusions happen, they obviously increase the ozone locally by very large amounts, and you can go into exceedance of these new limitations.
Going beyond 75 parts per billion not only means more of this, it also means states risk paying a fine.
So in order to qualify for exemptions, the states need to be able to prove that the high ozone levels observed at the surface did not happen because of local pollution emissions in that state. The GEOS 5's ability to represent the stratospheric intrusions and show how ozone is transported to the surface at certain times will give them a very quantitative way of being able to do that.
GEOS 5 is a high-resolution computer model. It can show us what's happening to the winds, temperatures, and chemical makeup of our atmosphere.
We'll be able to use GEOS 5 to estimate how frequently we expect to see such exceedances.
High-resolution modeling can help us understand how what's happening up here can impact the air quality down here, and why an otherwise crisp, clear-looking day might not be the best for a hike after all.